Okay, good morning, good afternoon, good evening, wherever you are in this beautiful world. I'm sure the current problem will be worked out soon, so let's hope that one of the next opportunities to see each other is going to be a live present workshop. But today it's going to be a virtual event. What are we going to do? We are planning to have a topical debate about the roadblocks for wide-scale deployment of autonomous vehicles. The next chart, please. So please, some housekeeping rules. All microphones are muted, clear, understandable, because it's basically a webinar. If you want to involve yourself, and I would really like to see your feedback, questions, and so on, you can use the chat feature. And specifically, if you have any questions, please feel free to use the questions to the speakers. Questions to the speakers in the first part during the presentations, we will answer maybe, maybe not, depending on time, but for sure you can be sure the questions will be forwarded into the debate section. Next, please. So in case there are any questions, use the Q&A function. I am going to forward the question to the speakers then, because I'm going to be the moderator. Next, please. So what is the idea of this industry connection group? We are in the forefront of standardization. The umbrella is the IEEE, IEEE being a standardization regulation company. Of course, yes, their interest is to pick up whatever needs to be done in terms of standardization, but we are not fixed to this only. We can pick up any issue, whatever is a hot potato in the industry, to guide into solutions for it. When I'm saying we, it means behind me, together with me, is the program committee. You can see the names here from BMW, IEEE, AVL, Bosch, NVIDIA. Myself, I worked at BMW till 2012. Since 2012, I'm working on my own as an independent consultant. Next, please. So first, we are going to start a poll. This debate about autonomous drive, when I left BMW, there was almost no one speaking about it. There was just some R&D projects internally, respectively on EU level, but that it's going to be a realistic view for the future, nobody did talk then. About 5 years ago, yes, it was the hot potato, and everybody believed, wow, it's going to come soon, whatever soon means. Today, it looks like people are getting a little more realistic. There are some stumbling points in the way, and at the moment, at least, there is no one really offering a system on level 4 or even 5 to be available on a wide scale. What are the problems? Why? Maybe vehicle technology is not so far yet. People don't feel it's safe enough or whatever, or sensor technology. Or maybe it's a customer acceptance. Is it realistic to ask someone to drive on a German highway with 130, 150 kilometers per hour without a driver? Do we trust? Or is it more coming from the cost side? Are people prepared to pay whatever kind of some additional money to be automatically driven? Or is it a question of regulations, homologation, which is not available yet, as far as I know, at least on level 4 or 5. So Rosie is going to start that poll section now. It will stay there for about 30 seconds. What you can do, you can choose the most important aspect from your point of view. So just feel free. You can't put it in a sequence. You just have to decide for the point of view which is the most important in your eyes. I'm going to use the result of this later on in the debate section. So please state your idea, and we will see how people are, what the opinion of the people is. It would be quite interesting to understand also the distribution all over the regions. I'm quite sure that the aspects of people in China and America and Europe are quite diverse. The world regions are, specifically in terms of customer acceptance, are quite different. So it looks like we are having our 30 seconds, Rosie. So that we can switch over to the next section. The next section will be that every speaker, that is interesting. Technology is the most important one. The second is customers not ready yet. Third is regulations. And the payment issue is the last. Okay, interesting. We will discuss this in the debate section. So let's go to the next chart, please. So we will start as follows. We will go through the world. First statement for United States, second China, third EU, and then we will have a view of a global OEM vehicle manufacturer. Everybody got about 20 minutes time, and please, our speakers, excuse, I will be quite strict on timing so that we are not going to run out of time in the end. In case there are questions, we will point them out as far as timing is allowing. In case we are running out of time, we will put the questions further to the debate sections. So first is Jack Wiest. Jack Wiest is working at Intel. He is the vice president of Mobileye, well-known guy within the IEEE world as well. He's the chairman of the IEEE 2846 decision-making for autonomous drive. Jack, you are on the stage. You did get up so early in the morning, so I'll have to hand over to you. Thank you very much for your contribution.
Thank you, Axel. It's wonderful to be here, and good afternoon, good evening, and anybody else is up on the West Coast with me this early. Very good morning to you. So first, I'd like to share a photo. This is a fun picture of the early days of the introduction of automobiles, and I think it's worth considering that the original introduction of the automobile was not quite so easy or seamless. At this time, roads were designed for bicycles, for pedestrians, for horse-drawn carriages. And it took some time for us to figure out sort of a social protocol on what was acceptable in terms of how these automobiles should operate. Traffic signals were human controlled, you know, with people at the top of ladders in intersections before we moved to automation with traffic signaling. And so it took some time to kind of figure out how this worked. So if we go to the next slide, I think it's worth wondering then, or considering, you know, what if as we introduce these driverless vehicles, if every automated vehicle on the road had its own kind of definition of what it meant for a machine to drive safely? Or what if every country in Europe or state in the US or province in China had a different definition of what it meant, you know, for a machine to drive safely? Or what if every time there was an accident or a crash involving an automated vehicle, let's say between two different automated vehicles even, it took a lawsuit and years of litigation to figure out ultimately who was driving safely and who was not. And so if we go to the next slide, we propose that the problem here is that unless we can come to an agreement on what it means for an automated vehicle to drive safely, there simply will not be automated vehicles. Companies are not going to be willing to take the risk, and deployments will be limited to small kind of geofenced areas in a low volume of vehicles, and the world will not benefit from this life-saving technology. So if we go to the next slide, I propose that driving safely as a definition is driving at a societally acceptable risk balance and proving that you're doing so. And I would suggest even we as human drivers do this today. When we take our driver examination, what are we doing? We are demonstrating that we know how to drive, both following the rules, but also in a manner that represents a societally acceptable risk. And the purpose of our driver's test is to prove that we are doing so. And so we think that same mentality should exist for machine drivers. And this is the challenge then that we have for industry. So if we go to the next slide, let's look at a very simple scenario. Let's look at a car following scenario. So here we have an automated vehicle that is following another vehicle. And so if you're following this other vehicle, we humans have things like the 2-second rule, or in Germany, you have a rule where you have the number of kilometers, and that gives you sort of the, you know, the distance that you should have. But these are just tricks for us simple human minds. For an automated vehicle, it's a machine. It's programmed, it has code, right? So it needs to be precise, and it can be precise in terms of what is the following distance that it should maintain. And so if you're trying to estimate or determine following distance, the deceleration rate of the vehicle that you're following is a significant contributor to how much space do you need. The greater the braking capability of the vehicle that you are following, the larger the following distance you're going to need in order to be able to guarantee that you could stop if that vehicle you're following were itself to suddenly stop. And so here's the challenge, though. If you look at vehicles on the road today, there is a significant variation in the braking capabilities of those vehicles. The Porsche, a Corvette, 12.5 meters per second. There are cars on the road that have 15 meters per second squared in terms of the deceleration rate. A truck, say a 2015 Ford F-150, quite a bit less than that because of certainly the size of the vehicle and kind of brakes that are in it. But NHTSA found, interestingly, that for human drivers, it doesn't matter what kind of vehicle you're driving. Human drivers brake pretty consistently with a small standard deviation of about 6.5 meters per second. So if a machine then, an automated vehicle, is going to calculate a safe following distance, which value should it use? Should it use what we know humans do naturalistically, which is what we human drivers do, right? We assume something more on the order of 6.5 meters per second, which means we are following too close much of the time to be able to guarantee that we could stop. That's why we have rear-end accidents from time to time. Or should you assume the worst case? If you assume the worst case value, now you're going to have very long following distances. the automated vehicles will contribute negatively to traffic flow, and people will not want these vehicles on the road. So what do? At some point, you have to pick a value which represents acceptable risk, which is a balance between perfect safety and still useful and practicable vehicles at the same time. So if we go to the next slide, our position is that industry's job here is to define these parameters, but ultimately is the role of government to pick the values. And these values represent acceptable risk. And government does this all the time. Every time there's a new road that is built, what happens? That road does not start out, it's not born with a speed limit. You know, the road is constructed and government has to pick a value for what is the acceptable risk of that roadway that balances all the factors. You know, are there pedestrians around or there not? Things like this. And so a speed limit and a value for that speed limit is an example of government picking a value that represents acceptable risk. If government wanted to eliminate fatal accidents overnight, we could set the global maximum speed limit to 10 miles per hour. And we'd be done, right? An incredible improvement in safety, right? But we don't do that because of the trade-off of the loss of efficiency. So government is very frequently in this position of picking values that represent acceptable risk, that represent then a trade-off between perfect safety and utility. There is another new regulation coming in the US very soon around electric vehicles. Many of us have been in a parking lot where an electric vehicle kind of creeps up from behind us and we didn't even hear it. And so there's new regulations coming for electric vehicles in the United States that says when operating below certain speeds, that electric vehicle must emit a sound of 62 decibels. Well, why 62? Why wasn't it 63 or 70? Wouldn't it be much better for safety if it was 80 or 90 decibels? Sure, right? More people would hear it, but at what cost? You know, maybe the cost of our own hearing or just the annoyance of this loud sound. So again, it's the example of a trade-off. But why was it 62? Why wasn't it 50 or 40? So again, it's a value that represents what is the desired level of acceptable risk. And so industry needs to help government by providing guidance on these are the parameters that represent acceptable risk in automated vehicle decision-making, but then government needs to pick the values. So we'll come back to this in a moment with the work that we're doing in IEEE 2846. But before I do that, let's take a step back and look at the global landscape of industry standards. So let's go to the next slide. If we look at what's happening globally, there's some excellent activity. So if we go ahead and build out the slide on the left. So first, how do you define or develop or test the device? Here's where you have systematic process standards that we're all very familiar with. Then you have safe by design architectures. And this is work that my colleague Simon is going to talk about next, ISO 4804 and 5403. So these would provide you guidance on how to architect something for an automated vehicle that is safe by design, not safe by trial and error. Then you've built something. Okay, now I need to test it. In what scenarios should I test it? We had the Pegasus project, and ISO Working Group 9 is working on scenario databases. So, okay, I've tested my vehicle in a scenario. I didn't crash. Does that mean I passed the test, or did I just get lucky? I don't know. This is where we need metrics. The Institute for Automated Mobility in the state of Arizona in the US is working on some metrics along with SAE, and the AVSC also just produced some metrics. But how did I test that vehicle? Was it in the real world? Was it in simulation? Was it on a test track? Should I be able to commercially deploy a vehicle that has only been tested in simulation? I don't know. Should I be able to deploy a vehicle that has only been tested in the real world? Good question, right? So the UNECE and the Validation Methods for Automated Driving group is working on some of these questions. And then, of course, we have these safety assessment reports, which give you an opportunity to document the entirety of what you've built. So if we go, click one slide forward, I would assert, though, that if all you've done is followed these standards, you've done an excellent job following best practices. And we should all be doing this, to be clear. These are all important standards that fulfill a very important purpose, as we just described. But you have not necessarily built a vehicle that achieves acceptable risk. So if we click forward, I would argue, and I'll introduce here today, that the only standard that is one that achieves acceptable risk is IEEE 2846. So it is a standard that provides a framework for governments to provide these values that represent acceptable risk. So let's learn a little bit more about IEEE 2846 on the next slide. So this standard that I am humbly honored to be chairing, Waymo is the vice chair, Aurora is our secretary. We have OEMs from VW to Ford, for example, Honda. We have tier one companies like Denso participating. We have government institutes like NIST, other mobility as a service players like Motional and Neuro. Silicon providers like Infineon and NVIDIA, of course, with Intel. And we have an incredible collection of entities here that are working together to align on this key question of assumptions. What are these reasonable and foreseeable assumptions that an automated vehicle can use when operating in the real world? And the example that we provided before was that car following scenario. What should I assume is the maximum deceleration capability of the vehicle that I'm following? So there's a foundational question for us in this standard. So if we click to the next slide, a key definition for us is safety-related model. Related model, which we formally define in this standard, is a representation of safety-relevant aspects of driving behavior based on reasonably foreseeable assumptions about other road users. So safety models like RSS from Mobileye, SFF from NVIDIA, rule books from Motional, these are all examples of safety-related models that are based on this notion of making a reasonably foreseeable assumption about the behavior of other road users as a way to operate safely in the real world. So if we go to the next slide, here was our methodology. We first identified what are the kinematic properties of road users that are relevant. We'll give us some examples of these. We formulated these properties into bounded assumptions. So now we can clearly define the boundaries of what is expected to be reasonably foreseeable and what the automated vehicle should be able to handle in the real world. We then identified some representative high-level scenarios, and in our standard we are showing how these normative assumptions can be used to illustrate the correct behavior within these scenarios. So if we look forward to the next slide, here's an example from our standard. Here is that simple car following scenario. Here we have the automated vehicle. We have some other road user. What is the assumption that we need to make? We need to make an assumption about the maximum assumed longitudinal deceleration. As we said before, is it that global worst case? Should we pick 3G here and have an incredibly long following distance at all times? Well, it would be very safe, but be really annoying, for lots of people on the road, and might contribute very negatively to traffic flow. So here's again where industry is providing the boundaries, the parameters, and we need government then to step in and provide those values. So if we click forward, we'll look at one more example here. Here, a little more complicated example, we have a pedestrian. In many cases, pedestrians, we think we have vehicles driving very fast right next to the road with pedestrians, perhaps because that pedestrian is on a sidewalk. Well, we as human drivers assume that if that pedestrian is on the sidewalk, they're going to stay on the sidewalk. Why do we think they're going to stay on the sidewalk? Because of what we observe about their heading angle and what we know intuitively about humans and their heading angle rate change. And so here in this example, even if we're talking about a scenario where a pedestrian could be in the road, we still make assumptions about what is the maximum assumed heading angle rate change. And with that then, combined with other values like the maximum acceleration, for example, of a pedestrian, you can calculate very precisely just based on physics. We have objects of mass and motion here, so we're not going to change the laws of physics anytime soon, that would allow the automated vehicle to make informed, reasonably foreseeable assumptions about those other road users so that it can navigate safely in the real world. And so this is an example of what we're doing in our standard. And as you can see, we think it will be a very useful framework for governments around the world. So let's go one more slide and I will finish up and hand it over to my colleagues. So to summarize, we think it is critical for industry and government to align on what it means for a machine to drive safely. If we cannot achieve this alignment, we fear there will not be automated vehicles. However, we have a definition for driving safely that is consistent with the human definition, which is that driving safely is driving at a societally acceptable risk balance and proving that you're doing so. And IEEE 2846 is the only standard that provides a framework for governments to set that acceptable risk balance by providing values or parameters in these scenarios that we have defined. So thank you for your time today. Look forward to engaging with all of you further on this standard, and I'm looking forward to hearing from my colleagues.
Thank you. Am I back? Rosie? Okay, thank you very much. Jack, there was one question by Max Turner. When we talk about an automated vehicle, are we talking about a robotaxi that can only operate as an EV, or also about mixed mode privately owned vehicles? Maybe we have time to just answer that quickly.
Yeah, very good question. Thanks for asking. The scope of our standard is for the automation levels. So anytime that the machine driver is in control. So under the SAE automation levels, that would be level 3 and above.
Okay, thank you. Okay, next chart, please. Okay, so next will be a statement from Bolin Zhu. Bolin Zhu is working at Qatar. Qatar is the Chinese standardization body as well as the representative of the OEMs of the automotive industry in China. Bolin, the stage is yours.
Thank you, Axel. So, hi, everyone. So thanks for the introduction, and I'm very glad to be here. So the topic for today is we're discussing the roadblocks for wide-scale deployments of ADS. And let's go to the first page where, I like the first page where Jack just showed it was, a mixture of, horse carriages and cars. So that was the early stage in the US. I'm pretty sure that was true. But unfortunately, this is the cases differently in China, where China was lagged behind from those kind of. So if I search, the Chinese Google, I cannot find a picture of that, including the Chinese, 100 years ago. So what was the case in China currently is that we have a, lag behind on, conventional and inner combustion engine, we're lag behind. But the good thing is we're pretty much catching up on this new trend, which is the electric cars, and all these things are linked with autonomous driving vehicles. So we can see there's a huge spike in data in China, and even though we're not increasing dramatically in the past few years, we still hold a huge market in EV and ADVs in China. So what do this mean? So go to the next page. So once we have all those cars registered in the country right now, what we do find out is that the government, unfortunately, in China played a huge role in all these things. When Axel was introducing me, there were talk about Qatar is the role in that. So with the China is pretty much like they're doing a 5-year plan. It's the history for the Communist Party. They do a 5-year plan, and they pointed out in different policies. Then since we are pretty underdeveloped, 50 years ago, then the infrastructure is pretty easy for us. We're building, long expressways and networks and across the globe, which I think the US achieved it probably 70 years ago or something like that. And then, you know, the fundings, because we're actually catching up, we're raising a lot of funds, and, you know, there's a lot of things going on. So things are changing dramatically in China. That's the case for that. So what does this mean? So we go to the next page. We see not only that, you know, we're policy-wise, infrastructure-wise are changing dramatically, we also have a lot of data going on. So if you compare the data in 2020, which is actually quite similar in the trend with also 2019 and 18, when you have access to open access data for testing in the area. So China has opened more than 30 cities in China. They're testing in major cities just like Beijing and Shanghai. And when we're comparing this, at the mileage, we're basically improving at a higher rate. So, you know, in Beijing and Shanghai, the collective rate is actually grow 10% higher than what they do in California. And you can see most of the country are doing tests in California, is also pretty much doing testing in Beijing and many cities in China. So there's a comparison we can do there. So what does this mean? So if we go to the next page, we can see that based on those kind of research results, you can see that we found that in China, the complexity of the scenarios are major cases. So if we look at the newest data, which provided by the testing areas in China and Beijing specifically, you know, there are 4 major categories, which is disengagement categories, which are system defects, algorithm defects, et cetera, we'll be seeing. And you can see that in this kind of rolling, you can see there are the rolling of data is being changing. So before we can see is immature in most of the technology. So there are issues such as map mislabeling, you know, hardware issues, EPS, etc. But when we go in further and further after more training, those things vanishes and go into new areas such as, you know, if we go to the next page, we can see more specifically, the cases are actually increasing. Those are unlawful behaviors from the vehicles or road users. And, you know, there are the cases in risky behaviors, you know, similar to what Jack was saying. And also there are different inaccuracy in the, you know, in the road signs and, you know, speed limits and all those things confusing vehicles itself. So what does this mean? If we go to the next page, you can see that, you know, we are basically in China, we realize the more data we have, the more scenarios we have, we're starting to treat ADVs or ADSs as human drivers. You know, as you also, the poll was showing at earlier stage, you know, people are not too fond of what actually the capabilities of ADS are and ADVs are. So what this do is, in China, you know, we like to develop kind of procedures, you know, procedures trying to figure it out. What can we do? Like, what kind of procedures you know, what kind of capabilities can be tested in the right form? So this is what the roadmaps in China in the past 3 years, and many things has been changed. Test area being opened, demonstration performance are being performed around the countries, and, you know, a lot of data being collected, and there's a lot of things can be discussed. So if we go to the next page, we figure out one of the major issues we have in China right now is we are very hard to define those things. You know, that's also a
Ich bin in einer Videokonferenz gerade, für die ganz schnell.
Ja, aber ich komme.
Okay, so if we learn from those data, we can see that it's a long tail problem. So it's not only because, you know, it's not because we don't know enough about what the cases are, but also the more cases we involve, the more cases we having, then you see that, you know, the cases will be a long tail problem. And this is the case where we're interested in, you know, accident data, in real data, in real driving behavior, et cetera, and this is the case. So what we do next with those data, we'll see in the next page, is that, you know, if we tackle this problem, that we need to set up a actual next 5-year plan to do this. So in China, what we do is we set up a guidance for next 5-year plan. We called it PEPMAC, actually. It's short for acronyms for Production Enterprise and Production Market Access Management Guidance, and attaching ICV, which is pretty long. The point of the PEPMAC is basically we're starting to requiring, you know, OEMs, you know, companies, and, you know, those or suppliers actually providing, what kind of thing they can do, what capabilities are, procedures, so if something goes wrong, we know there is a procedure, we can go back there and find, oh, okay, what's the problems, what the problems are. And, we're starting to have some entry level kind of, requirements, you can do what kind of simulation testing, test track, cybersecurity, et cetera, et cetera. So this is the case. So what do we have so far? If we go next page, we see that those are the examples we actually collect the data on the roads. So the roadblocks, what are the roadblocks? There are a variety of different signs. There are a variety of different kind of, objects and actually different kind of, tricycles, bicycles all around the country. So those are the data we collected on highway. And you can see that it's not necessarily unified with, a country with such huge size. And, and those things are hard and very good example for the ADVs to learn and actually to do something about it. And this is what we're actually trying to provide. So there are many cases in that. So if we go to next pages, and we can see there are even more examples that, the vehicles are actually being towed, there are various of objects and missed guides. And as also being shown in the previous chart, we're actually saying, most of the cases are unlawful behaviors in China are, people are just cut in too close to the ADVs and all those things we saw. And those things are very valuable. In a way that it's pretty much useful for the companies and for the people who are interested in ADV and applying to them. So if we go to next page, this is the thing where what my team in Qatar is doing is that we are basically trying to analyze it. We're trying to see a variety of different kind of machine learning or methods that to do so, that you try to categorizing them, trying to make everyone understand on the same page what kind of data we're having and what kind of things we do. And similar to what Jack was just mentioning about the IEEE 2846, if I said it correctly, those sort of things are pretty helpful to giving an input for, figure out what the risk of and assess access, for that as well. So look at the next page. This is a typical thing I'm doing probably even 2 years ago. And this is what we see is that, we're having this proposal saying, okay, what do we do? Like, what do we know about doing turning, left turn, right turn? Does they acting, symmetrically? Does people do that in a way? And can we get actual model for doing so? And as you can see, people actually, you can see the variety of it. There are very hard to find a very, 95% of confidence intervals, where people can actually gathering all the behavior. So this is also echoing at the start of the question with the poll is that, people don't know too much about how ADV works. And people don't know too much about how ADS works. And, this kind of things like if we treated, ADV as, another kind of a creature, it's like, a sociology kind of problem, are they acting similar to us? Do they do exactly what people expect them to do in a way? And can we understand their behavior? So the data does provide a lot of infos in that kind of direction. So if we go to the next page, we see that more varieties in kind of different variables and more varieties of that. And this is the thing definitely showing across the board in China that it does create a huge variety of that. And this is quite crucial to tackle the long tail problem. So if we go to the next one, similar to what Jack was saying, we're starting to evaluate what kind of things are quite risky. So we're sampling all those problems, and then to do that, as what also Jack was mentioning earlier, there should be a long tool chain, for scenarios measuring. There are metrics talking about there, and there are different kind of validation kind of methods, and we trying to pick or cherry picking all those things could be crucial to that, and those things could be expanded not only in China, but also global knowledge. Why? So that's also why Qatar is also interesting in exchanging all those data across the globe and also creating, different kind of working groups all over the globe that, we can exchange more knowledge about how people behave and how does people are afraid of, ADVs in a way that, we can accept them at the end of the day. So if we go to the next page, we can see that the whole process will be done in this way. So we're starting, for the government side, we're starting to do, talking about different concepts in different ways. And we start to utilizing and stylizing scenarios in different kind of resources and all those kind of things. And, all those things can be extracted, experiences from those databases. Then we do all the processing. We're trying to utilize and uniforming the whole process in this way. And this is where all the PEPMAG I was mentioning earlier are kind of, matching up. We're trying to strengthen this kind of path through all the way. Then eventually all those experiences can be done through different variety of scenario databases and all those testing procedures. And this can make us learn a little bit better of AAV itself. So what do we need to do in this kind of way? So look at the next page. We see that we need to talk more about understanding each other. So, we should start to understand what the system concepts are and how do we define them, what things can be done that way. And also, can we have access to different kinds of scenario database so those things can be exchanged on a global scale. Then what do we do for verification? What do we do for validation? Excuse me. And also, what kind of things can be done in those whole ways? And this is something the Chinese government and Qatar is working heavily in the next 3 or 5 years, and it will be the cases. So what do we learn from this? We go to the next page. We'll see that from this, we see the past, we are very unclear what we're actually defining and what kind of level we're talking about. Then nowadays we're lacking of what kind of supervisions are. If you're up to cases in China, we see that Tesla's having a little bit of trouble in China actually, because they're creating they're starting to rolling out this kind of faulty kind of brakes, and people don't know exactly happened, and people get more scared about what Tesla. So you can see there are there are bump stickers everywhere say, oh, please don't follow me, Tesla, or something like that. This is the cases. People are too afraid of what's going on because they don't understand what it is. So those kind of creating a society phenomenon, and those things are not helpful. And Qatar is at this position where trying to open this up and trying to see everyone, it's not that complicated in a way. And once we found out where the problems are, you can treat them as a human driver. So this is the last thing. This is something we do heavily in this year. Next page, we'll see that we're basically combining different kind of ADV, scenario databases, from accents, from naturalistic driving data, from regional data, and then we're creating language which could be exchanged. Like today, everyone's talking in English, which means that everyone can understand each other, what we do actually do in that kind of cases. And similar to that, scenarios as a way of exchanging people understanding how, how vehicles are behaving could be also applied as a language for the ADVs and ADSs. And the long tail problem actually helps people to create, a dictionary, to create actual textbook that tells people how those things behave, and then we can evaluate them. And this is the way we're doing. So at the end of the day, which would be the last page, which is exactly go back to where the problems are, all the way we're talking about the roadblocks in China is that as, a country with lack of, a lot of histories in how people understanding how the vehicles behave. Actually, if you ask my parents, when they were young, they don't see vehicles on the road a lot. They don't really understand how vehicles behave. And then to nowadays, everyone's like only a car in this country, and the dramatically change and all that. Then the problem we're tackling is we need to make sure everyone could understand how eventually ADV behaves in China, and that requires a lot of understanding of how scenario works, how testing works, and how common knowledge and common languages are existing in the ADV system and ADV world. And that's all I have for today. Thank you for your attention.
Thank you very much, Bolin. We have one question from Kashra from Sweden. He's asking, I believe that these data collected in autonomous driving vehicles as today are pretty biased because they are mostly coming out of vehicles which are supervised by a safety driver. So is it realistic or not? And secondly, the disengagement rate may not be the perfect measure of performance. So can you elaborate on that a little bit, Pauline?
Absolutely, absolutely. So thank you for the question, Karsra. I definitely agree with that. Similar to what Jack was starting, he was saying, the distance between the vehicles and itself are quite biased by the driver, or even the vehicle type, as was mentioned earlier. I think that was the idea, and that's true. But on the other hand, it is a way of we understanding people, understand the world. So my background was on data analysis and data science. We know that in the world, how we do this is something we call a Bayesian kind of statistical methods, which is, we have a prior knowledge, say, okay, drivers are pretty biased in this region. We have that proposal and prior knowledge of that. Then we have a lot of, train data. We have a lot of thing going forward, and then we understand a little bit better. So eventually what we think of is, if we only looking for the data with safety driver, those are quite not that important. That's not quite accurate. So what do is we trying to improve different sources, not only the one we collect on the roads, but also maybe those things are collected on, notice to the driver, or even the things are actually being traced back from an accident. So to expand the data source is the way we're doing. So second question is, the disengagement rate is not a perfect measure of performance. Absolutely. So this is definitely the cases, but those things can be translated into an experiences, or something like a threshold or even a constraint that help us to understand that. So eventually, similar to how people tackling the problems in the natural world, we don't understand everything, how physical laws works and everything. But with all the experiments and all those experiences, we know a little bit better, and that is the right way, at least we believe, in both in China and globally, how to tackle this problem. Thank you.
Thank you very much, Wally. Okay, then let's move to the next page, please. Okay, next we will have a statement from Europe, Philipp Schreiner. Philipp is the head of the Autonomous. The Autonomous is an organization of OEMs and first tiers, global, and he should have a good overview where people or companies in the European Union are standing. Philipp, it's your turn.
Thank you very much for the nice introduction and also for the opportunity to talk to you today. So I would like to present to you the Autonomous. It's an initiative, so I have a little different previous speakers. But in a nutshell, safety is essential also in our context. So I think the fit is quite well. And so I will just jump right into it. On the next slide, actually, I want to just elaborate a little bit what we understand within the term safety. So of course, with under this term, an enormous number of challenges are laying underneath, ranging from safe software architecture to how we're actually able to verify safe AI, to cybersecurity, big topic itself, regulations, or the whole homologation part, the challenges on sensor fusion, and the list continues, almost endless. Sometimes I have the feeling, yeah. So I don't believe we can say one particular challenge of this is the one and only roadblocker for the deployment, which is basically the question of today's discussion. So rather, I think it's the combination and the interplay, and especially the ability of the industry to deal with these challenges. And to be even more precise, I think it's important to find a common understanding of what safety is in all these different levels. So this goes totally aligned also with Jack and Pauline, but it's just a different perspective on how to look on this. So in order to overcome these challenges and tackle these challenges, it needs collaboration. So the collaboration part is really the key asset that is needed in order to make autonomous driving a reality. So what is the Autonomous doing in that context? On the next slide, you see our vision. So actually, we are trying to solve the biggest safety challenges. So you can find all of the ones I showed before, by enabling this collaboration. So we see the Autonomous really as the facilitator, as platform where this joint effort should be taken on. And while we do this by really changing how the industry is currently working. So that's a big mission and a big vision we are totally aware of, but I think this is really the only way to deal with it. So how do we do this, and what do we mean with changing the way the industry works? So on the next slide, there is a very easy schematic display of, on the left-hand side, the current approach. So the current approach of a development process within the automotive industry. Yeah. So it's only a schematic view, but I think it shows quite relation between OEM, some tiers, tech companies, etc., and they're trying to solve a concrete problem. In this chart, we say problem A. This happens simultaneously in parallel with another corporation. So actually, different corporations are solving the same problem with a different solution. This works quite well so far. I think it's nothing against it, but we believe if it gets more complex and the topic gets more complex, this approach is not reasonable anymore and not feasible anymore. That's why we propose the approach on the right-hand side to really say, okay, let's come together on the single ecosystem, on a single know-how ecosystem. The more companies on it, the better. And jointly develop, we call it global reference solutions. So to say, really examples, reference example solutions for particular safety issues. Doing is actually we're expanding the collaboration phase. What we don't do is we are eliminating competition, for sure not. Yeah, we're just expanding the collaboration phase, and it's indicated here on a step 2 that actually, of course, on top of this common understanding, which we then generated, the companies are putting it up. And by this approach, by this proposed approach, we are believing that it's in general better for the products itself because we are developing safer and better products jointly. We're going to reduce the risk of product liability, which is definitely a huge risk for companies operating in that industry. Of course, development costs and also time. And we also believe that it reduces the risk of wrong development. So this is what we are trying to do. And to say a few words how we actually tackle this and how we're going to do this on the next slide. You see, yes, who we are talking to. So what is the ecosystem that we are involving? What is the target group of the autonomous? And it's not only the let's say the traditional automotive industry, but also like governmental institutions. So we are working closely with governmental institutions to also get their opinion and also see how far are they with their working groups. As well as we call thought leaders, for example. So individuals that are really pushing some ideas forward in the industry. Disruptor companies, so companies that are doing the job completely differently. Yeah? As well as academia, research institutions. So in a nutshell, we want to do this in a very holistic approach. So, well, when we say the biggest roadblock is the way how the industry collaborates, what do we do actually in order to change this? And you can see on the next slide, the activities summarized from the autonomous. So on the left-hand side, you have the event stream. Some of you might know already the autonomous main event or our chapter event. So basically, it's on virtually or also physically events, trying to bring the top executives and experts together to really facilitate the networking, facilitate also the discussion. So this is what we do on the one hand side. And on the other side, the innovation stream, we do really where the actual work is happening. And we're very proud that we actually are close to kick off our first working group, which I will tell you later a little bit more information. But not only working groups should be possible, also more intense collaboration opportunities should be able within the autonomous platform. So very, very briefly, just a few words on the innovation, on the event stream. If you go on the next slide, even one more, you can see what I just briefly said. So the autonomous chapter events is a new format that we developed last year and was quite successful. So we were able to engage with more than 1,500 experts. And the idea of these chapter events was to actually ask the industry, ask the experts, what are the blind spots where you say common understanding is missing, common safety understanding is missing. And it developed very well. So we were actually able to conduct chapter event reports after each event, which now serve for us as a pool of ideas and topics to actually go further into a working group. Besides that, the main event is going to take place again this year. So it's good that the vaccination is keep on going, and then we make sure that the rates are very low in order to make a physical event. Anyhow, we're planning it hybrid. So actually it will be possible for attendees and speakers to participate virtually as well. So this is really the flagship event from our side to connect the executives and experts. Right, the next page, please. More highlights or more focus now I want to put on the innovation stream. So especially on the working group side. Next page, please. So because this is really where the actual work is happening when I say, you know, a global reference solution or common to design a common understanding of safety. So what we are trying to do, actually, we try to find means to innovate. So how can we make sure this collaboration I said at the beginning is actually happening? And you can do that on various ways. Here indicated is that the working groups are the ones that we are starting with, but we're not limited to working groups at all. We can also go further and really say, okay, if industry partners are willing to go together and do some pilot projects or even joint ventures, we want to make sure to make it possible to be the facilitator in order to do this. But step by step, so I'm going to now focus on the working groups. Here, the idea is to have 2 phases. So we are currently in a phase 1, so actually really trying to formulate jointly recommendations, best practices, guidelines that can be then also attached to existing and relevant standards. So that's how we're actually contributing to the existing standard landscape. So we're not aiming to be another standard, for sure not, because I think there a lot of good work is already happening underneath ISO, underneath IEEE. But what we want to do is we want to actually add additional benefit by formulating reference solutions, formulating recommendations, guidelines, etc. And through a very close alignment, we also make sure that our work fits into what is going to be discussed in the standardization working groups. So to be even more precise, next page, please. Yes, one more click. And here you can see the details on our first working group on safety and architecture. So the idea is to actually make it possible for all topics to be covered on the autonomous. We don't want to limit us on architecture or AI or cybersecurity. We want to become a forum, an open platform for all potential topics. But you have to start somewhere, right? And we're starting with safety and architecture. And the idea is really to focus on level 3 and 4 and above. So let's say from level 3 onwards, to really define these common understandings. The kickoff is actually quite soon, in June this year, and we are now in final stages in getting the partners on board to be able to kick off in about a month. And the output, the concrete output in this, what I just said in recommendation and best practices, is done in the form of a technical report, a technical document that is also then being released after each cycle of the working group. There are going to be different variations of these reports. So some of them will be publicly available with certain information. Some of them are only available for the members of the working group. And I think I reached the end of my presentation, and I think I also was quite in time. So I'm very looking forward to the discussion afterwards. Thank you.
Thank you very much, Philip. And there is a question of Max Turner, and he's asking if this joint approach on the OEM level is really realistic. Of course, every OEM is fighting for his customers. They are competing to each other. So is it realistic to bring them together?
So I have to answer with yes, because we are already talking to various OEMs that are actually committing to join us in the working group. And because, of course, as I said before, we are not focusing on the competitive parts, right? We are focusing on the safety critical parts that in the end, it's benefit for all companies to have here an alignment and a common understanding. So it's not the differentiation aspect, it's rather the commodity, so to say, that we are focusing on. And it works. So it's already a proof of concept.
Okay, I really hope so. And you will like this question of Kasra. He's asking how to join the autonomous.
Yes, so if you want to join the autonomous, just go to our website, that-autonomous.com. You can find the request form here and just apply and tell us how you want to contribute, and we contact you individually. So there are many ways of becoming active, from events to the working groups. And yeah, we really just talk to everybody and see where the fit is best. So just reach out to us via the website.
Okay, thank you very much. And it's a pleasure that we are so nicely in time. So let's go to the next. So next is our OEM statement. This will be coming from Simon Fürst. He's working at BMW Group. He's the principal expert for driving technologies. The idea here is to have now, we had the views from the United States, from China, from Europe, and now the point of view to bring everything together, because for a global car manufacturer, of course, it's not so easy to react on different thinking, different ideas, different whatever per country or per region. So Simon, the stage is yours.
So can you hear me and see me?
Yes.
Okay, so right now I'm online. So Axel, thank you very much for this very nice introductory words. So to bring everything together right now, this is the challenge I have to face in my presentation. So let me try to summarize an OEM's point of view on how to really bring automated driving on the road. So can you go to the next slide, please? So what is changing by today? So I think it was very nice at the very first talk. Jack started with, let's say, a look back, and here right now we have the look at today's situation. I try to give an outlook into the future where we will go to. So as you can see by today, the whole industry or the whole situation of the transport of traffic is basically mostly owned and a little bit shared. But the whole story is about strict regulations. They are differently, of course, in country and regions. They are about traffic lights, signs, and all this kind of stuff. And of course, the key parameters, the accident statistics, what the whole story is about. But in the future, of course, the direction goes much more into shared and automated technologies that release the individual driver from taking the boring task here to operate his vehicle in the traffic jam. It's also, of course, about regulation for this automatic traffic. It's more about quality of life. And of course, it's about this ultimate goal of the zero target vision. And this zero target vision, when you read this, of course, it has two zero targets. It's zero emission, and of course, it's zero accidents. It's 2 times 0 to take it precisely here. So let's see where we go on when we go to the next slide. So let's talk about the vision of zero accidents. Of course, this is nothing what you can bring to the road immediately with automated vehicles. Here you have to definitely start with something realistic. This is where I definitely like to follow up and also join the same, let's say, words as already given by Jack Wiest at the beginning. The whole story is about a positive risk balance. So this is something that has also been derived from the German Ethics Commission report by mid-2017. And here the key idea is automated vehicles must be safer than human drivers. They do not say how much safer this is and how they differentiate between the different geo-regions where we have different exit statistics. But at the end, I think this is a kind of target that will be accepted by the people, by the population. This is something that is socially acceptable when we have a positive risk balance. And of course, how to realize that, how to handle that, how to bring this to the road with different markets and different vehicles. This is the very big challenge right now. Is this one magic number at the end we will have worldwide, or is this more or less a number that we have here in Europe, and there we have a different one in China, and then another one in the US. So this is where we have to jointly work on as different, let's say, automotive OEMs and then the major players in that market. And of course, this might differ very much, not only from the region, but also from the different types of roads. So if we have the highways with high-speed driving, we have the urban roads, and of course, it also depends on age and weather of drivers. So, the target is easy to understand, but bringing it down to a clear number, this is a really big challenge behind that. But as we also do not want to have that at the end, we bring a vehicle to the road and then we demonstrate the positive risk balance and then everything is fine. This is something that is not an acceptable approach here. We say we need to also follow this principle of avoidance of unreasonable risk. So what is this saying at the end? So this means you develop the system according to the well understood, let's say, also handled principles of developing safety-related systems. And these safety-related systems always achieve a minimum safety level from the very beginning. So this is what we have defined by today very well in ISO 26262 as the ultimate safety standard for automotive industry, gets supported by this new SOTIF standard that is just upcoming. And this is here saying positive risk balance is the proof at the end, but when we start the avoidance of unreasonable risk by doing a really safe development from the very beginning, this is the second main pillar we have to follow. So let's continue on the next slide and bring this down a little bit to a more technical point of view, because this was the nice point on the voting of the different reasons why we don't have automated driving on the road. And I also voted for it's still a technical challenge. And this is here right now, the 12 principles we have derived from this top level goals that we need to consider and to further detail, of course, in a technical system at the end to develop safe automated driving systems. And I think you can read them out much more quickly than I can explain them, but let me highlight a couple of them. So one, I think that is very important is on the left-hand side, the behavior and traffic. And this also is going into the same direction where Jack was already providing some more details. But here the key statement is, for a very long time, we will have mixed scenarios. So this means some automated vehicles, but the majority, of course, will still human-driven vehicles. And the human driver, they need to be in a position so that they can, let's say, predict what will be the behavior and the expected behavior of the other road participants, independent if this is human-driven or automated vehicle. So making the long story short, also the automated vehicles need to have a very similar driving behavior than the automated vehicle, than the manual-driven vehicles, so that at the end, a human driver can predict an automated vehicle the same way as it would be with a human-driven vehicle, so that we can properly react and will not cause more accidents due to different behaviors. And another very important point, and this is written here, is user responsibility, vehicle-initiated handover, and the handover from the operator to the vehicle. When we talk about customer vehicles, level 3 vehicles, then you always can drive them manually as you do today, and you can turn on areas and ODDs where it's possible this automated driving mode. And the whole human-machine interface must be designed in a very stringent and clear way so that it's always clear, is the machine driving or is the driver really under control of the dynamic driving task. So this must be a crystal clear situation within the vehicle. Another point I like to really focus on, this is in passive safety. So passive safety is saying all the safety mechanisms we have in the vehicles by today, they need to be kept in the vehicle, and there's no reason that you take them out to save money or for whatever reason. So the airbags is shown here in the small pictogram, they still will be part of automated vehicles in the same way. And last but not least, it's also very important to focus here on security or cyber security, to be more precise. So this is the clear understanding. Automated vehicles will always be connected vehicles. They always will have a connection to some backend services for getting road approvals, clearance, additional traffic information, and so on. And this means they have interfaces to outside systems, to the cloud, to say it in simple terms here. And of course, all these kind of interfaces need to be really hardened from the security point of view. And this is a very important point here right now. It's of course also today's vehicle, they have interfaces, but these interfaces in general do not have a direct impact on the driving of the vehicle. But with automated vehicle, this potentially will be the case. And so for that reason, hardening this from the security point of view is ultimately needed. So let's go to the next slide and go a little bit into the technical details here. So please go on one slide before that. So with the architecture, can you go back one slide, please? Okay, thank you for that. So with that slide here, I like to give, let's say, a picture on a very generic architecture of a level 3 system. What is the key statements you can see here? So there's a main channel and there's a safe channel. So here the key understanding is that there's a certain kind of redundancy in the system where you, let's say, do the sensor evolution and the sensing and the perception is two independent channels. They might also be developed independently and have a slightly different task. One is really its main channel doing the comfort driving at the end. And the safe channel, of course, is doing more or less the supervision that, say, the driving of the main channel is still safe, or in other terms, is free of any accidents. And this is at the end validation and selector, well-known principles from the safety. But of course, this is something how we need to have a monitoring system of the main channel here so that we can control the main channel to avoid any accidents. And in case this main system here on the lower part of the picture has any failure, then there must be a fallback level. And this is on the upper part of the picture here. This is a fail-degraded channel. And here the main target is when the lower part has a total failure, for example, due to power loss. And there's a second power supply for the upper part here. And this second power supply, of course, needs to be redundant and available. And then this safe channel has the main task to execute the minimum risk maneuver and to bring the vehicle in the minimum risk condition. So this at the end typically might be just 30 seconds, might be 1 minute, depending on where you are driving, what is the driving scenario, but it's really a short time at the end of the day. And here the key statements are on the right-hand side. So the main channel, this is the performance, what the driver generally feels, what really makes the whole ride comfortable at the end. Then the fail-safe is the supervision of that, so that the drive is accident-free. And fail-degraded means that you need some kind of, let's say, limited fail operational mode for a certain amount of time to bring the vehicle always in a safe position. And right now, let's go on to the next slide, please. So this is right now the global picture on how to achieve this. So all these ideas we have brought together in a white paper that was released already quite a while ago. Then we forwarded this into ISO and created a technical report as a kind of global technical statement out of that. And right now, at the beginning of this year, we just started working on the ISO technical specification 5083. So this is a new working group 13. In the TC22, this is road vehicles, and there's a subcommittee 32, where this standardization activity is taking place. And the standardization here is, let's say, the central part where we say this gives the global guideline on how to develop safe automated driving. On the left-hand side, you can see inputs from national regulatory committees. Of course, this is something that needs to be in sync, and the arrow goes to the right direction here, but of course it also goes to the left direction. So what the standardization is doing here, of course, is something that is also considered by the local authorities doing the regulatory part. And also on the right-hand side, it's very important to understand not only regulatory we have to fulfill to really provide acceptable and safe customer products. We have the customer protection authorities. ADAC in Germany is very well known. NCAP, of course, is very famous. And also the top safety pick in the US. This is customer representatives that make tests, they do the vehicle testing and give also a certain ranking for the vehicle. The left-hand part is needed from the regulatory point of view to get homologation. The right-hand part is at least as important as this is needed to get customer acceptance at the end. And this is the inputs we need to bring into a safety standard for automated driving so that at the end we can jointly bring these products to the market. And this is all taking place under the umbrella of developing safe automated vehicles. So it's not touching at the end the competitive behavior itself. It regulates the safety. And let's come to the last slide right now. So this is a little bit more details on the global picture here. So it's showing what's really going on in a worldwide scenario. This is, of course, something we have to update continuously. But here the regulatory thing is in the center, because the regulatory at the end, it's really what you have to pass to get the road approval for your system. And there we see three major regions on the world. This is UNECE, this is the European Community, and Korea and Japan is very closely attached to that. This is something that works in a quite big geo-region. Then we have US, is mostly been driven by NHTSA, and of course we already got the very nice talk from Qatar on the situation in China. And of course, there we have dedicated inputs from different standardization bodies shown here on the left-hand side. On the upper left, you also see research projects that always help to gain new ideas, new input. And this, on the one hand side, goes into the standardization, it goes into the industry, but there's also an exchange and a link with the regulatory side. And also very important is on the right-hand side, the traffic rules. This is something I just explained. This predictable behavior is, of course, very closely linked to traffic rules. And also here, a global solution needs to be adaptable to any kind of global traffic rules to have the appropriate behavior. And when you see this, we have very common traffic rules here in Europe, and we have, let's say, slightly different ones in the different states of the US, and the same is also for China. Even cities can have very dedicated rules. And this, when you sum it up, is a really big challenge from global OEM to cover all this in a single product and the end to bring the safe automated driving to the road. So let me conclude here right now with my last slide. So it's our understanding, so here's the last slide, so I hope you can see. That's our understanding that in the center of all that, we bring these aspects together with an ISO standardization. This was already explained, this project I had been talking about, and here the target of that TS 5083 is really safety for automated driving system covering level 3 and level 4, because this is what will be brought to the road in the near future. And for that reason, here we address all the different aspects so that we at the end are in a position to create a global product at the end of the day that is really safe wherever you operate it. So thank you for listening, and let's have an interesting discussion and a Q&A right now. So I hand back to you, Axel. Thank you.
Thank you very much, Simon. There is another question from Max Turner. He's asking, how would the principle change, simplify, if we focus only on robotaxi cases?
Currently, this is not part of our discussion, but of course you can, let's say, for example, reduce these three principles. So can you go back some slides, please, Rosie, where we have the principles, then I can more easily explain it. And one more, please. There, that's it. So as I explained, there are a couple of principles that are dedicatedly focusing on user responsibility and the handover scenarios. And when you have a robotaxi, of course, this is getting less relevant or even not relevant at all. So there are certain parts that you can at the end take out here. And of course, typically when you have robotaxis, you have a very dedicated ODD that might be differently here, but this is covered in a more general manner here. But I think the main change really is to answer Max Turner's question correctly, is the issue of the handover that here takes place while the vehicle is in operation. And this is something that will not happen in a robotaxi.
Okay, and the last question from Max Turner as well to Simon. Would you say that the hardware-software architecture you showed also works for a level 4 vehicle?
So the architecture I have been showing here is architecture that was designed for level 3 and level 4 systems. But of course, when you look into the details, Rosie, can you please go forward one slide, then we can better have a look at that one. Okay, so this architecture here, in principle, works for level 4, but of course, depending on the ODD of level 4, the kind of sensors, the number of cameras and lidars might be very differently. So it's my clear statement here, in principle, yes, in detail, of course, there will be relevant differences. And when you, for example, have a system that can handle very complex urban scenarios, you might need a much more complex main channel compared when you have a system just doing a traffic jam pilot for highways. But the principal architecture should work for both scenarios.
Okay, Rosie, then let's go to the next page, please. To my charts, please. Okay, so we are jumping over now into our discussion session. So I would like to ask the speakers, please, to change their heads now a little bit. You all did understand very well the global issues, but now you have a regional head. Only Simon is allowed to think globally, so to say, just to enable a real debate here. So first question from my point of view, just to start with Jack, you started with the point socially acceptable risk. And of course, this is automatically triggering the question, is there a world level of acceptable risk, or are the acceptable risks related to regional attitudes, social backgrounds whatsoever? So is it possible to design a car in the end for Simon, which is able to handle or to work along the lines of one standard set of social acceptable risks, or do we have to differentiate the vehicle per region? Jack, you started that, so maybe you elaborate a little bit on that.
Sure, thank you, Axel. That's a very good question, actually. And the way that I think about it is that, in short, no, I do not believe that there is such a thing as a universally common set of values for acceptable risk, but the concept is similar. But the key is that people, and as Bolin would certainly tell us, people drive very differently in Shanghai as they do even in the rural parts of China. In Europe, people drive very differently in Italy maybe than they do in Germany, or Switzerland. And so acceptable risk is always a relative analysis and understanding. And so that's why we believe that any framework for acceptable risk needs to be flexible. And so the IEEE 2846 standard, for example, that's why it defines the parameters, but not the values. And so that way governments in different regions, or even within a single country, you could have different values for dry weather or snowy weather, or you could have different values for these parameters on urban roads versus an interstate or autobahn. Because of that relative difference in understanding what is risk in those different environments because of the different contexts. So it's important that this notion of driving safely and acceptable risk be something where the definition is flexible and can be different in different countries, but also so that we can tune it over time. And as people get more comfortable with the technology and the mix of vehicles goes up compared to human drivers, again, the values for some of these parameters could change if the majority of the vehicles are automated vehicles instead of a mix of automated and human vehicles. So it's a very good question, and driving safely is cultural, and we need to make sure that our regulatory and standards approach can represent and embody those cultural differences.
Yeah, that's what I waited for. So Simon, what does it mean for you then? You're I'm just imagining I'm buying a car in Europe and I'm going to export this car to China or whatsoever from one region to the other. Do I have to reprogram then the related parameters to acceptable risk? What does it mean for you?
So basically what you're addressing here is the real big challenge at the end. So assuming that we have a product that suits, let's say, speaking as BMW for the German market, I think it will be quite straightforward to bring it to other markets here in Europe, other countries where the behavior on the road is quite different, like US and even more in China. Of course, this will change, but at the end, I think the design criteria is exactly as Jack said. This must be always an acceptable risk level. And due to the fact that also the average driving scenarios, and this is what Pauline was talking about, are very much differently in different countries, at the end, even when the system from the technical point of view is very similar, the risk level at the end might be a different one due that you're not driving on your own on the roads. There's always a lot of traffic around you and you cannot control everything. But I think at the end, the regional market has to accept the risk that comes from these vehicles. And I think it's more important not to compare the different markets. So the key, let's say, success point is that the different automated vehicles have the same level of safety. And that there's never ever the saying that buy this vehicle from manufacturer A because it's much more safe than that one from manufacturer B, because then it would no longer be acceptable by the population of a certain country or region. And there's where we need to work on common standards to achieve exactly that point.
Yeah, that brings me, Simon, to a key question in terms of differentiations between OEMs. Of course, acceptable risk level, safety, as you called it, has to be on a standard value. It can't be that a BMW drives with a higher risk within the traffic than whatever other brand. So what is the differentiating USP, if there is any way possible in a USP in an autonomous car, differentiating a BMW in your case from whoever, from other cars?
Let me try to give an answer on that. So I think in an initial phase where this technology gets introduced, it's simply also the ODD. So when BMW can drive in an automated mode on roads where others cannot do so, then of course it's a differentiating factor. But let's assume that we all can cover a very similar ODD, then I expect also that the driving behavior is very similar, because when you're not driving on your own, you like to have a comfort mode, otherwise you get seasick in your own vehicle and things like that. And then at the end, it's more the overall comfort of the vehicle that really makes the difference. And the audio system, the connectivity, the leather and the seats, and that's really important. They are important by today, and potentially they become more important when you're just a passenger.
Okay, makes sense. Unlawful behavior, Berlin. Also, of course, it triggers the question. The amount of unlawful behavior in China, if everybody believes in, and from my own experience, of course, I think everybody of us has been in other regions and understands that unlawful behavior in China is something very different from a highway in America or a German Autobahn. So is it possible to have a standardized set of unlawful behavior to be programmed somehow into the vehicle, or has this to be a localized set of parameters or even set of behaviors?
So the question was, so that's a very good question as well. So as I was mentioning earlier, a lot of things we did in China, we found out the thing that the ADS was incapable of doing is the unlawful or the cases like that. But, in a way, once we talk about, lawful or not within the regulations, it's basically, at the start, there is a written script of what lawful is, right? So there's one thing doing that. And the other one, of course, as also Simon was mentioning, is the ODD. So, we categorizing those as not only unlawful, but also outside the ODD, because at the end of the day, the vehicle's ADS are not capable of actually, reflects, to those kind of things. And those are quite interesting because if we want to expand knowledge of it, which is a lot of the Chinese OEMs and also the Chinese companies are doing, is that, okay, I'm driving this in Beijing, it's Beijing, if you went to Beijing, they draw the roads in a ring, so second ring, third ring, fourth ring, etc. So I said, okay, I'm totally capable of driving this car on the ring roads, inside of a ring 2, and it works perfectly fine. Then they say, okay, if this is the thing, then we can definitely tackle this problem by, saying, oh, ODD works only in Beijing ring 2. Then, eventually they're expanding it with not only the lawful kind of data, but also unlawful. And then this can be expanded, eventually roll out to the whole country. And that is quite crucial. And this kind of procedure is the data, scenarios, and, long tail problem where how do we tackle them? So, yeah.
I'm just thinking about driving behaviors specifically in China, in the north of China. Driving behaviors in China are quite different to the south, it looks like. For example, in Shenyang, where I lived for 1 year, unlawful behavior, I can't really imagine how an automatic vehicle will move even 100 meters when he has to switch off always when some other vehicles are changing lanes and so on in unlawful behavior, because that is just standard. They are using, if it's a 3 lanes road, they are making 5 lanes or whatever out of it as a normal behavior, socially accepted, to come back to Jack. But being unlawful, on the other hand, even in China, but it is generally accepted. So what do? Then your automatic car never starts?
That's a good question. So at the end of the day, I think that the direct bottom line is, maybe if you train with those unlawful things, the vehicle's acting, so at the end, okay, maybe I should try a different way. So maybe unlawful, socially acceptance. Do you want the autonomous driving drives lawfully, right? Within the regulations, or do you want it drive like a normal driver, as people acting on the roads in China? So if you want the first one, then what you put in there, the scenarios are the lawful ones, right? If you want someone who actually drive, like the normal Chinese driver, you probably want to involve a little bit, unlawfully way of driving. But at the end of the day, we want to regulate them in a way so we can tell them, if you involving a lot of that, maybe this is the case where you're getting in troubles, and those things are not the one that we wanted. So so far as we know, OEMs in China, the people are actually trying to improve the road qualities in a way that they don't want to involve all those unlawful kind of unlawfulness. So all the scenarios they're using are within the regulations and laws and ODDs, and those things out of it should be eliminated through the whole ADS system and eventually in this process.
Interesting concept. I'm really still, to be honest, a little bit confused to imagine an automatic machine-driven car in North China traffic, really. But I know it works. AutoX, for example, and Shanghai is driving successfully, but this is a big challenge still, yes. Philip, you were talking about this combination of all knowledge in the industry and the world to bring together the OEMs to solve the challenges. It looks like your first working group is on safety and architecture. Architecture means usually you have to start about 4 or 5 years ahead of production. Isn't it a little late to think now about the feedback of safety safety ideas into feeding back into architectural demands?
No, not at all. I think we believe it's better to start somewhere instead of not starting at all. So it's never too late. And what we of course do, and there's a lot of work going into this, is the so to say all members that are contributing and working with us in the working group, bringing them to the same level. So the idea is not to work on things that are already passed, rather to say, okay, you know, what is the basis that we have to build on, maybe because it's compulsory, it's something that we can't change anymore, and what is actually there still modifiable. So this is of course something very individualized, depending on the members, but no, it's not too late. It's never too late. And the good thing is that we are also aware of that. Right now is a good time actually, because many partners and members are actually in the process of a transformation phase. So they are right now reconsidering and restructuring also on the architecture side. So if you ask me, I think it's actually the best timing to do it now. But I think maybe, yeah, the OEM, Simon, you can also add your perspective here.
Yeah, that's of course what I would have liked to pass on. Simon, you mentioned your architecture, and okay, this was a very generic architecture as you showed it, but of course it goes back to a real architecture in terms of the EE fundamentals. In 23, 24, I did pick up, you are waiting for the regulations to homologize a level 4 car, but the architecture for something which is going on online in 23, 24 was decided 2 years ago already. So how does it go together?
Yeah, so basically what I think, when you like to standardize something, does not matter what it really is. You need a couple of, let's say, groups, people, companies coming together that have a certain experience in that field, so that you can find, let's say, the common resolution or the common, let's say, architecture in our case. And you cannot do this in a greenfield approach, to my understanding. And for that reason, I definitely have to follow Philip's argumentation. You need some partners that have a certain initial experience on the architecture, and the companies that have worked on that really have done a lot of analysis on the right architecture. And when you have all this knowledge and IP at the end collected, then you can come together and really try to find the common ground and then to standardize that. But starting from day zero with a standard on something like that, I think this is something that typically does not work out as the best solution at the end.
Okay, we have a question from Furkan Eke from Luxoft. Luxoft, I think, is a Russian software company, if I'm rightly informed. How will this work with self-certification?
Belongs to HP right now.
Yeah, right. So Simon, I think self-certification is more your issue.
Okay, I think the question on certification is always a critical one, because certification is a not well-defined term here. And what I have been talking about, of course, there will be regulatory rules. And the question is, to my understanding, when you talk about certification, you're asking for a certain degree of independence who is validating that your results and your, let's say, sign-off is done correctly. And I think when you have a look at the global markets, the US is working in such a way by today. Here you can bring the product to the market on your own risk, and in case something went wrong, then it's also on your own risk. And for that reason, I think we have a long history with a certain approach from the US with self-certification. And of course, it depends right now on let's say, on the overall behavior of the automotive industry, how carefully they take this and how much they focus really on safety, so that you can keep this something that is more flexible than in the aerospace industry.
Yeah. good point. Bolin, self-certification in China is not really, let's say, the number one process to adhere to. So what would you say to self-certification in China?
So as I was mentioning earlier, there was a document or a direction where the Chinese government will do is because they realize how difficult it is to set a bar for everyone, how to do this and, for everyone. And it's hard for that. So they were definitely considering, the Chinese government is definitely considering self-certification. So you have to show your capabilities, how you can test your vehicles, how do you test your products, and how does this perform, can be compared to others. So eventually, what will be exchanged is not only the all those kind of metrics or data in itself, but also the procedure level, how do we do quality controls and all that will be involved, at least in China, how this is going to work out. So that's the situation.
Okay, we have another question from Curly. Curly Freighter is currently trying to set up a test site in Gondwana, so the Queensland in Australia. So he asks, when will world governments come together to create a universal consensus roadmap? Roadmap, I assume, means roadmap in terms of introducing level 4, level 5. And is this on any agenda? Who can answer that? Philip, maybe you got some ideas about it.
Well, yes, I think if you interpret it like this, so concerning level 4, for example, I think Germany made a huge step forward in the last couple of months as they announced the first regulation becoming in place. So actually one of the first countries worldwide. Actually, I believe it's very unlikely that we have a global perspective on that because it's really just so different on countries and different needs in different countries. But I think what we can definitely we should try to do, and we should actually also have a big focus on, is to have a certain alignment in some aspects, especially on the safety side. Yeah, and this is what we're trying to do on the discourse level. So we are talking with NHTSA, we are talking with the European Union to also don't leave them out, to give them impulse. But of course, the regulation and the actual framework, the legal framework for each country, yeah, it's not something that you're going to have much power on, especially if you're planning to have a global scale. So I think this is unrealistic, but yes, there is definitely need for more exchange and actually to learn from each other. For example, with data pooling or with other projects like this. And one partner from our side, so the World Economic Forum, does this on a high level already. Yeah, but I think it needs more activities towards that.
Okay, I'm just going back to our poll questions.
Axel, can I also give a statement on that point?
Yes. Oh, of course, I like it. Yes, very much.
Yeah, definitely. So, of course, on the one hand side, this looks like a great scenario. I definitely have to agree on. But what we also currently see is there is a certain kind of competition pushing this topic forward. Yeah. Also, what was just mentioned by Philip is the level 4 regulation. France is doing something similar. So when there's a kind of competition between the different geo-regions, between the different countries, this is bringing the whole thing forward. Not only by the competitors on the market, the OEMs and the other players, but also when there's a national competition between the countries. Also, this is giving a push to the whole story. And I think not having this globally harmonized would slow down the whole process and potentially would even stop it at the end of the day. So I think you have to think twice about this question in detail, if this is really the target we like to go for. Not saying that I like to have a totally defragmented scenario here in the world. Yeah.
Yeah, I think that is a principle.
Somewhere in between, most probably.
Yeah.
Yeah.
The balance is
Yeah.
the solution to my understanding. Yeah.
Yeah. Okay, just to change the topic a little bit, I did ask the guests in the beginning, what do they see as the biggest stumbling point in the way of mass introduction of machine-driven cars? So the choices were the technology is not available yet, customers are not available, or are not on the acceptance yet, customers are not willing to pay, or the regulations are not available yet. So 50% of our guests, and I assume these are mostly engineering-driven people or with an engineering background at least, they believe that the technology is not ready enough. That is, for me, a little bit surprising, to be honest. So could you elaborate on that? Maybe starting with Bolin, please. I think we go around to everyone because this is a statement I would love to understand from everybody's point of view. So do you agree that the technology is not ready yet? Bolin?
So that results for that polling is quite intriguing because, as you were mentioning, people from the engineer background probably will tend to say so. I will, if I put my engineering hat on, I probably will say that too. It's that is the lack of the things we're actually having. But for my other side, which Target's also doing a lot of collaboration and also international kind of, as I mentioned, scenarios, those things are definitely helpful facilitating that. So there are solutions, and we are actually on the way to finding the right way to tackle this problem. And that's what I truly believed in.
Okay. Okay. Nevertheless, AutoX in Shanghai, and then as far as I know, they are running robot taxis even on level 5 without a safety driver. So at least within this ODD, it seems to be possible, because otherwise you couldn't run on that risk, right?
Absolutely. So I took those rides as well in both Shanghai and also in Guangzhou. So they're doing well. I can also see them improving. The one I took in November and the one I took in May, I think there's definitely improvements in those small nuanced differences in small areas. So it's evolving. I would say it's definitely evolving. And, we set a target for level 5 or level 4, then people will catch up and the technology will evolve. And yeah.
Okay. So let's pass on the same question to Jack, thinking in United States conditions, and Waymo, as far as I know, in Phoenix, is running as well without an operational taxi robo system. So do you think the technology is ready, or isn't it?
Yeah, no, I think the biggest challenge is really just the opportunities for everyday consumers to have an experience with the technology. It's still, we are all here very lucky, in the sense that we have had firsthand exposure and are working on the technology ourselves. And so we in the industry, I think, have much more confidence than the average driver because of our opportunity to experience the technology firsthand. So I think one of the trends that I think is going to help here considerably is that for most people around the world, their car still has a very basic driver assistance functionality, or maybe even no driver assistance functionality at all, depending upon the age of your vehicle. But over the next, 3, 4, 5 years, as people refresh their cars, increasingly they're going to have a car that has advanced driver assistance functionality built in. And at the end of the day, that's the foundational technology that is used for driverless vehicles. And so I think as consumers get more exposure to more advanced kinds of driver assistance, their familiarity with the technology and their comfort in the technology and their belief in how well the technology works, because they'll have experienced it while still driving, is going to increase. And then I think we'll start to change some of the public opinion about the readiness of technology for driverless vehicles. So we think that increase in the deployment of more advanced driver assistance systems is going to have a significant and positive impact on the public's readiness and willingness to embrace fully driverless technologies.
Now that leads to the next point of view of customer. Do they accepting the level? But let's stick on the technical aspect first. So Philip, what would you say? Is a technology which is available now, or let's say within the next 2-3 foreseeable years, is it ready for mass introduction or not?
I think it really depends on what we see as, or what do we define as a wide scale, and what do we define as mass production. Yeah. So for special ODDs, yes. For what I think, if you ask the public, now to jump to the public topic as well, what do they understand on the autonomous driving? They see themselves sleeping in the car and going from A to B, right? Regardless of the conditions, regardless of the roads, etc. So if we talk about this scenario, I think we're not there yet, but it really depends on what do you define as what counts as wide scale, and partially, yes, partially it is ready. The technology is here. Coming back to the original question, I think it's really difficult to say it's either the technology or it's the public acceptance or something else. I think it's really the combination here. So it actually, one thing also influences the other thing. So if technology proves to be ready, if you have showcases in cities, etc., of course the public acceptance will very quickly rise. So I think you can't say it's either one or the other. I mean, from my perspective, of course, from the autonomous perspective, again, we say, okay, all is actually here. So we have a table full of tools, if you want to say, you have everything ready. The only problem we have is we have to put the right people together actually to make it happen. This is our philosophy. That's where we are coming from. Say, okay, it is possible, but we just need to place the team together, place the right puzzles together in order to make it possible. So it's I would even add a fifth one. It means lack of collaboration. Yeah, that is the reason for, which sums up quite everything, in my opinion.
Yeah, makes sense. Of course, it's if we join forces, everybody together to have the one on, somehow standardized car. Somebody is really, they are bothering me here. Sorry. So the idea to combine forces of the industry on one target here, of course, makes sense. Simon, what would you say from your point of view? What does it mean? Are we really ready in terms of technology? And I mean L4, 23, 24, are we ready to sell the cars, not to run it as a test car under whatever kind of specific conditions?
So I think the first observation you have to make is, up to now, there's no end customer vehicle on the market that has a level 3 system. Yeah. This is a clear fact, and I think this is the reason why most of the participants gave this answer. And from that point of view, of course, it is correct. Yeah. But I definitely see that technology and the overall ecosystem that you need for features like that is right now getting ready to get these L3 systems on the market in the next 1 to 3 years. And of course, this will not be from the very beginning a highway pilot that can go up to 130 kilometers. It will be, let's say, a very small ODD, so that also the vehicle providers and the manufacturers can get their first, let's say, experience with such kind of system. And for that reason, I'm quite sure most of the offers that we will see will start with something that is a traffic jam pilot. this is quite well understood scenario. You have other vehicles mostly driving at the same very low speed on slow speed on highways. And so I think this is where we have to start with. I think this was, let's say, the wrong understanding when the hype was at its peak, that everybody thought that level 5 systems will be ready within the next couple of years. And right now we have learned that we have to start with, let's say, relatively small ODDs and in a step-by-step approach. But fundamentally, I think the whole thing is right now understood, and we understand how to really build the solution. And this is something that will definitely happen over the next couple of years.
Yeah, I can accept that. Makes sense. One of your colleagues, or one of our colleagues, he always said, if the world is going to look for driving fully autonomous over the Stilfseer Joch, which is a big mountain here in the Alps, in the fog, then this idea will not happen really in the foreseeable future. And I agree with that. So coming back finally to the social acceptance, we have, according to many questionnaires which are out all over the world, young people are much easier to accept technologies, new machine-driven cars, while the elder people, at least here in this case, I'm referring to a questionnaire here, they are referring to people who are older than 25 years. They don't trust as much as the young people. Is this going to be a stumbling point, really? Because the young people, yes, they may use it, but they will never buy it. The buyers of vehicles are usually around 40, but these guys are relatively critical about machine-driven cars. Is this going to be a problem? So in the end, who is going to buy the cars? Jack, do you have an idea?
That we can do to help relieve any concerns is transparency with the public about how the technology works. I think historically there's been so much competition between different players and so much secrecy about how the systems work that secrecy does not create trust. Transparency creates trust. And so I think as more of the industry comes together and collaborates on key standards like 5083 and 2846, we have consensus-based standards that show transparency and openness about this is how the system works, and this is why we believe it is safe. And as we can communicate more of that information to the public, I hope then that the public will have greater confidence and a greater understanding and awareness of the technology, that it's not just a secret black box of AI. There's actually well thought and design and good safety principles that are behind the design of these systems. So I think industry needs to continue to commit to transparency, but also industry needs to continue to do a better job of communicating where we have gained consensus and communicating information about how the technology works to relieve the concerns of people who are understandably have important questions about how does it work.
This is just such a nice, beautiful final statement, Jack. I really love it. And I'm sure, Philip, you would like to underline that so that everybody joins the autonomous to come to global solutions, combining all the knowledge of the world. Isn't it, Philip?
Well, Axel, what should I say now? You just made it very clear and perfectly. Yes, and I mean, in the end, it's I think this change in thinking of the industry. So what I showed also in the presentation, right? So this current approach and the proposed approach, yeah. I mean, standard activities are actually doing already the proposed approach, yeah. So from a standard perspective, we're already there. I think from defining and really coming up with reference solutions, with examples, etc. Even going further with maybe joint development at some part on the safety critical parts, there is a lot of potential. I think this is now the time to do it, to really, to make this transformation possible.
Okay, this is really a beautiful final statement. I love it, because working together, this is also my personal point of view. This is why I'm doing this kind of global discussions, trying to bring the industry together. This is really something we can only solve together. Of course, we have to accept different conditions, social acceptance, different traffic conditions, different historical developments, and so on, clear. But in the end, I like this word of transparency, what Jack mentioned, and what the autonomous is creating, and what BMW anyway always is trying to achieve, to be as open as possible, to convince the technology-driven part of the society, as well as the critical part of the society, not really convinced yet that automatic machines, like a complex car under conventional conditions, can work like that. Okay, I'd like to close the session now. I thank you very much for all your input, and hope you all are going to have a nice day, afternoon, or you are going to sleep wherever in the world you are. So we need the next, So please, all the guests, please fill in the feedback chart. And what I would love to mention mainly is put your text in, your ideas, whatever you would like to see, additional topics, elements you would like to have discussed in this format. The main idea of this format is to bring global people together. Yes, it's a little bit ugly for some people in terms of going to get up early or going to bed late. This is unfortunately can't be avoided on a global format. So what would you like to see to be discussed in this kind of format? The next chart, Rosie, please. The idea, as I mentioned already, by this group is to bring the global community together. Very much like almost every attendee in this round already referred to. Only by working together we can achieve the targets, what is worthwhile in the end, what we shall have, what you would like to see. So if you, next chart please, if you would like to bring up any idea, what should be discussed in this format, so the next chart please. There is an email address. Bring up your contribution, either forward to me or to the IEEE, whatever kind of contribution, whatever question you are going to bring up, please. Thank you very much. It was a pleasure being together with the world. Bye-bye, and this is the end. Ciao. Thank you very much. Close the session.
Bye-bye.
Thanks to all the speakers. Thanks to the ladies behind. Thank you. Bye-bye.